Okay, the 14th and final topic in Module 1 is histograms. Now, histogram is a bit like a bar chart, but the area of the bar is what indicates the number instead of being the height of the bar. For example, here's an exam question, very difficult to read, very small. I'll read through it. The examination scores of a group of students are summarized in the table. There are 10 people who got between 0 and 20 for their score. There are 18 people who got between 20 and 40. There are 25 people who got between 40 and 50. There are 20 people who got between 50 and 60. There are 16 people who got between 60 and 80. And there are 2 people who got between 80 and 100. So we're going to draw a histogram for that. So once again, it's a bit like a bar chart, but it's not about making the heights equal to those numbers. So we're not just going to make 6 bars that are 10, 18, 25, 20, 16 and 2 high. First of all, we're going to calculate some things from what we've been given. So I've extended the table and I've written class width and frequency density. Now, class width is how wide these categories are. So from 0 to 20 is a class width of 20. It's called class width because on the graph it's going to be the bottom of the bar that we draw. So it's how wide that bar is going to be. The second bar is going to be from 20 to 40. From 20 to 40. So the class width again is going to be 20. But the next bar, it only goes from 40 to 50. So on the graph it's going to be from 40 to 50. 50 minus 40 is 10, so the class width is only 10 for that one. The next one, it goes from 50 to 60. So again the class width is only 10. The next one goes from 60 to 80, so the class width for that one is 20. And then the last one is 80 to 100, so the bar for that one is going to go from 80 to 100, so it's going to be 20 units wide. Now, when we draw a histogram, we want the numbers that we're representing, which in this case are the frequency, the number of students, to be represented by the area of the bar. So if a bar has an area of 10 and the width of it is 20, then the height of it must be a half, because the area of something is calculated from the width times the height. So if the width is 20 and the height is a half, 0.5, 20 times 0.5 gives you an area of 10. So we're working out how high each bar is going to be by dividing the frequency, which is going to be the area, by the class width. So 18 divided by 20 gives you a frequency density, as it's called, of 0.9. That says 18 divided by 20 equals 0.9, so that we have 0.9 times 20 equals the frequency, which is 18, because we want the frequency to be the same as the area of the block. So I've started doing these on the graph. There's that one. So the bar goes from 20 to 40, so it has a width of 20. It has a height of 0.9, so that the area of that bar is 18. Okay, the next one, we want the area of the bar to be 25. The width of the bar is going to be 10. So the height of the bar, which we're calling the frequency density, has got to be 2.5, so that the bar is 10 wide, 2.5 high, and the area is 25. And there it is. 10 wide, 2.5 high on the vertical scale, which we call frequency density, makes the area of the bar 25. Next one. Frequency density equals 20 divided by 10, which is 2, so that the bar is 10 units wide, 2 units high, making the area 20. Next one, 16 divided by 20 is 0.8, so that the bar is 20 wide, 0.8 high, making the area 20 times 0.8, which is 16. And then the last one, the area of the bar has to be 2, the width is 20, so 20 divided by 2 means that the height of the bar has to be 0.1. So the bar is 20 wide, 0.1 high, making the area 2. Question B says, a merit is awarded for a mark between 48 and 75. Calculate an estimate of the number of students awarded a merit. Well, first of all, let's just put a key on our graph saying that 5 little squares represents 1 student. You can see that because, well, for example, from the first block you've got 50 little squares representing 10 students. So, a merit is awarded for a mark between 48 and 75. So I can highlight that on the graph, between 48 and 75, and see how many little squares that is. And we've got the fact that 1 little square represents 0.2 of a pupil, because 1 pupil or student is 5 squares. So 1 tiny little square represents 0.2 of a pupil. So 192.5 squares, which is what we've got here in red, represents 38.5 pupils. Okay, here's another one, slightly easier to read. The histogram represents the times that a number of runners took to complete a race. So remember, it's the areas of these bars that represent the number of people, not the heights of the bars. 10 runners completed the race in under 20 minutes. How many runners completed the race? So those are the ones that completed the race in under 20 minutes. And you can count how many little squares that is. In fact, if you count it, it's 100 little squares. And we're told that that represents 10 runners, because it says in the question that 10 runners completed the race in under 20 minutes. So 100 squares represent 10 runners. So a single square must be 0.1 of a runner. And in the whole thing, there's 700 squares. So that must represent 70 runners. So the answer is 70.